Hi and welcome to this next video in the probability series where we are going to dive straight into Venn diagrams and some probability concepts. These here are examples of Venn diagrams and they're a great way to give a clear picture of the interaction of events. These are all examples of two events within a sample space with shadings indicating different ways of selecting parts of the whole. The first looks at the whole of A. Then here, what has been selected is in A only and not in B or the rest of the sample space. Here it is then B only and not A or the rest of the sample space. Then this next example shows the overlap of A and B, in other words, the area they have in common. And then here, A only, B only, and the overlap of A and B have all been selected, and we refer to this as A or B. And then this final one is everything in the sample space other than A or B. We will talk more about the notation during the video. It is important with Venn diagrams to know that there are three types of ways information can be displayed. These three ways are the number of elements, the actual elements themselves, and probabilities. Let's have a look through an example of each of these. So first, let's look at when the information displayed is the number of elements. Here we have 20 students in this sample space, 10 of whom play tennis only, 7 play hockey only, and 3 play both tennis and hockey. As you can see, the number of students is given in each case. Then, when the information displayed is the elements themselves, in this sample space we have the first 10 natural numbers displayed, where A is the even numbers and B the odd numbers. You may notice that the overlap is empty. We will say more about this in a bit. Lastly, let's have a look at when the information is displayed as probabilities. For this example here, you are given that the probability of A and B, which is the overlap, is 0,2, the probability of A is 0,3, and the probability of B is 0,9. We can place the 0,2 in the overlap, but then in order to fill in the other probabilities, we will need to do some calculations. So the probability of A only will be 0,3 minus the overlap 0,2, which equals 0,1. And then B only will be 0,9 minus the overlap of 0,2, and so this here must be 0,7. Note that for this example, 0,1 plus 0,2 plus 0,7 equals 1, and this means everything in this sample space is in A and B. There are two representations of Venn diagrams from the beginning of the video that I'd like to give a bit more focus. The first is the union of two sets. This refers to the entire area of A and B combined, and we write this as A or B, or we can use the notation A union B. Elements in A or B can exist in A, or in B, or in both. And this is true for both overlapping and disjointed events. The second representation that I'd like to give more focus to is the intersection of two sets, which refers to this area where they overlap. Elements that appear in this intersection must belong to both A and B, and we write this as A and B, or we can use the notation A intersection B. A helpful way to remember which way around the notation goes is by thinking of this as an N for intersection, as opposed to the U for union. Now let's consider what is true for any two events by looking at the following example. Here the number of elements in A or B is 15 plus 5 plus 30, which equals 50. Then if we look at the number of elements in A and the number of elements in B separately, we would need to count the 5 twice. And so to make sure we don't count the overlap twice, we add the number of elements in A and the number of elements in B and subtract the number of elements in the overlap. In other words, for any two events, the number of elements in A or B equals the number of elements in A plus the number of elements in B minus the number of elements in A and B. and by dividing through by the total number in the sample space, in other words, by applying the definition of probability, it can be concluded that for any two events, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Let's use this same example to calculate the probability of A or B. We start by finding the number of elements in A, then in B, then in the intersection of A and B. We then find the probability in each of the cases by applying the definition of probability, in other words, by dividing through by the total number of elements in the sample space. Then we take the formula that is true for any two events and substitute in the probabilities we have just calculated. In this case, the answer for the probability of A or B is 1, which tells us that all the elements in this sample space lie in A or B. Now that we have discussed the general situations between two events, let's move on to some special cases. The first is mutually exclusive events. Events are mutually exclusive when the common overlapping area between them is empty. This means the events have no common elements, for example, odd and even numbers. You may remember when we listed the first 10 natural numbers earlier in this video, we placed all even numbers in event A and all odd numbers in event B, and their overlap was empty. This is an example of mutually exclusive events because a number cannot be both odd and even. So if we follow this logic, we can see the following to be true. For mutually exclusive events, the number of elements in the intersection of A and B is 0, which means the probability of A and B is then 0. And so, if we then consider the rule that is true for any two events, we can see that this last bit is 0 for mutually exclusive events. And so it is true to say for mutually exclusive events that P of A or B equals P of A plus P of B. And so if you need to prove events mutually exclusive, you can prove either this true or this true. Or if you are told events are mutually exclusive, then you can claim either of these two equations to be true. Our next special case is complementary events. Two events are complementary if they are mutually exclusive and if together they make up the entire sample space. And because they make up the entire sample space, the sum of their probabilities is 1. And so for complementary events, these statements will be true. The probability of the one will equal 1 minus the probability of the other. And then just in terms of notation, complementary events can also be written as not A or A dash as shown here.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.